Hello guys, welcome back to another video. In today's video, I'm going to be showing you how to solve equivalent expressions problems for the SAT using only Desmos. Let's get straight into the video. Alright, so here's the first problem. What I want you guys to do is pause real quick and read the problem and see if you can work it out on your own, and then try using this method. Alright, so the first thing you're going to want to realize for this problem is that it says the equation above is true for all x, which is something very important, and I'll show you why later. And a and b are constants, and we need to find what a and b are. Now they're giving you an equation and setting it equal to another equation. This is identical to what equivalent expressions means. We have an expression and we're setting it equal to another expression, and they should be equal for all the x that they tell us, which is all x here. So how do we solve this problem? Well, we're just going to do a simple regression where we just rewrite the equation and set them equal, but instead of using an equal sign and x's and y's, we use x1s, y1s, and a tilde sign instead of the equal sign. So let me show you how that works. So we're going to rewrite it ax, but instead of ax, we're going to write ax1 plus 3. That's just regression notation. It's good to memorize where to put your ones. X1 squared minus bx1 plus 4 is approximately equal to, it is equal to, but we have to put the approximation, cubed minus 9x1 squared minus 2x1 plus 12. Now, the value you get for a here is a little suspicious. Why would a be negative 0.375? That doesn't really make sense, right? And especially if you look at the answer choices, this was a multiple choice question. That's not possible, right? So how do we get a, b? Well, x1 is assumed to be 1 here. As you can see, it says x1 equals 1 right here, which doesn't really make sense. We're assuming it for all x values. Why are we only focusing on one value where it could be multiple things, right? So what we do is x1 equals and then put brackets. And these brackets are we're going to make a list of items where x1 can be, which makes the entire equation true. So let's just do 1 to 10. 1 dot 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 10. Always 3 dots in ellipse. And when you do that, it'll put all these values down here you see from 1 to 10, and it'll test it for x and tell you your values of a and b, which make those true. And which makes sense for the question because it's true for all x, right? We should be able to do 1 to 100 and it stays the same, which is perfect. So our value for a, b is 24. Now, really quickly, let me show you what would happen if you hadn't put the x1. Here's what would happen. X may not be used as a regression parameter. Try using a different variable name. This is telling you that x is for functions. When you want to graph functions, when you want to test values for x, it's a variable. You can't, x1 is assumed to be a constant, and we assume to be a constant that's in like any number. That's why we did our brackets earlier. So you have to put the x1, and you have to put the x1 equals 1 dot 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 10. That's to get the proper answer for these equivalent expressions problems. It's really fast if you practice, and in the problems coming up, you'll be able to practice more. Alright, so this one's going to be a little bit different, but if you can do this one on your own and practice using my method, there is no doubt that you'll be able to do it quickly. Just pause real quick if needed and read through it. Alright, so this question is another equivalent expressions problem. As you can see, they give us one function and they set it equal to another, and there's constants, and they're asking for the value of those constants. However, we have to realize that we can't do exactly what we did last time, because this is not true for all values of x. It's only true for values of x that are greater than 2. So I'll show you how to deal with that in a second. But first, we're going to do our standard regression, where we do 2x1 minus 2 plus 3 over x1 plus 5, x1 plus 5, approximately equal to our x1 plus t, x1 minus 2, and x1 plus 5. All right. As you can see, we have those weird numbers again, where none of the answer choices will match up with what RT is here, which is 8. None of those answers will match up because we're assuming that x1 is equal to 1. And specifically in this question, that can't be possible. And generally, we don't want it to only be equal to 1. So what we'll do is, we'll do the same thing we did last time. But instead of doing 1 to 10 like this, like we had done before, which obviously creates an error because there is an asymptote, what you have to do is, instead of it being 1 to 10, we have to be greater than 2, right? So what's greater than 2? 3. It has to be greater than 2. You can't use 2. You do 3, and then you can do it to 10. Or you can do it to 15. It doesn't matter. And now you have values for r and t, so our answer would be 20. And that's how you solve this equivalent expressions problem. Alright, so these next two problems are going to be extra practice on top of the two problems that you just did. because these are going to be a slightly easier, but they're just showing you what else they could ask and in what manner they can ask it, so you're really ready from the test. Alright, so this question is telling us that in this expression, blank, p is a constant, and the expression is equivalent. That should be a red flag that we can use our equivalent expressions regression technique that I have done in previous problems to set it equal to that other expression, and for all values of x, unspecified in this problem, so we can use all values of x. What is the value of p? So 3 times 2x, 1, don't forget that 1, it will not work. I'll show you what happens when you forget the 1, plus 8 minus 16x1 times p plus 4 is approximately equal to, it is equal to, but we have to put that for regression purposes, x1 plus 24. Now we get values here that don't really make sense for x1 and for p. So what we have to do is understand that x1 is not only equal to 0, it's equal to all values, right? It's not only equal to 0. It's an improper assumption. So we have to do our technique that we have done previously, where we do x1 equals to brackets 1 dot 10. There you go. That's testing all those values, and it's telling you which value for the constant p is true for all of these elements, which is 1 to 10 for x1. So our answer for p is 7. P is 7. Alright, so this is the final equivalent expressions problem, and it's a little bit easier, but again, I just want to show you guys like what they could ask, because there's not really much apart from this that they can ask, and I want to make sure you guys can drill the Desmos and make sure you actually work fast during the test to have extra time on harder problems in Math Module 2. So here they tell us that the expression above can be rewritten in the form ay squared plus b, and written in the form is another way of saying equivalent expression, that we're just setting that initial one that we had equal to this, and what are the values of the constants when that is equal to this. So what we're going to do is rewrite a regression. We're going to write 7532, write it just as they give it to you, with the exception of, since y is a variable, we're going to be putting 1 on the bottom, squared plus 10 times 10y1 squared minus 110 is approximately equal to, it is equal to, but again, we have to put that to make sure the regression comes out properly, ay1 squared plus b. Now these values may be correct for a and b, but we have to again reassure that y1 is true for all values, so we're going to do y1 equals 1 10. And now these are the true values for a and b, so when they ask us for the sum of a and b, the value of a plus b, we're going to do a plus b, don't even have to copy it, and you get 6,632, and that is the answer for this question. Thanks for watching. I stand by the Desmos method as it allows you to work faster and ensures accuracy. As you can see here, it helped me tremendously, and I want to share that knowledge with you guys too. Thank you very much.